Hello, calculus class. Today we're going to do 3.7b, optimization. So just like before on optimization, we need to really read to see what things are given to me. And we're going to write a primary equation. And that's the one that's going to be maximized or minimized. So that's the one we're going to take a derivative and set it equal to 0. And that's what's being asked about. And then they're going to give us enough information to make a secondary equation. And again, we take that and we solve for a variable so we can substitute back in the primary. So then the primary is in a single variable. Again, we need to worry about domains and extraneous solutions. And again, a max is when the derivative goes from positive to negative, and the max or a minimum is when the derivative goes from negative to positive. So the first one, we have an open top box is made by cutting congruent squares out of the side length x of the corners of, in this case, a 20 by 25 inch sheet. Bending the sides up, how large should the squares be to make the box hold as much as possible? Now, if the box is holding as much as possible, that is basically saying the volume is a maximum. And then it says find the maximum volume of the box. So let's figure out what we need. If we're going to cut x out of the corners, all of those would end up being x. Now, if this whole side is 25, this portion would end up being 25 minus 2x, because we have an x cut out here and an x cut out here. So we need to subtract that. So that's why that portion would be 25 minus 2x. Now, using that same logic, this portion right here would be 20 minus 2x. So our volume is length times width times height. Well, my length would end up being this portion. My width would be this portion. My height would be that portion. So volume is equal to x times 25 minus 2x, and then times 20 minus 2x. We could take a derivative of that, but that's going to get extremely nasty. So I would personally FOIL and distribute the x before we get going. So our volume, I'd still have this x chilling, and then when we FOIL, my first would end up being 500. My outers and inners, they'd combine to negative 90x. And then my last, negative 2x and negative 2x, become positive 4x squared. So now I'm going to go ahead and distribute the x, and I'm going to put it in descending power ordered. So x times 4x squared, we get 4x cubed, and then minus 90x squared, and then plus 500x. So that's our volume equation. From there, I'm going to take a derivative. So my variable is x, so my derivative would be dv dx. So we do the power rule, so then we get 12x squared minus 180x plus 500. Now, we're going to set that equal to 0. We can factor out a number, so 12 and negative 180 and 500, they all can be divisible by 4. So now we have 4 times 3x squared minus 45x plus 125. And so normally what I like to do to quadratics is factor them. I like to F them up. However, that one is not factorable. So what I personally would do is, because this one was going to require a graphing calculator, I would take that and graph it. And then I'd solve for my zeros. And so I would end up solving for my zeros, and I'd end up getting x is equal to 3.6812, and x is equal to 11.3188. Now, only one of those makes sense. And the one that makes sense is this 3.6 This 11.31 does not make sense because if I were to substitute an 11 something into x right here, that length would be a negative, and that would not make sense. That would give me a domain issue, so that is an extraneous solution. So how large should the squares be to have my box hold as much as possible? It should be 3 by 6.812 by 3.6812. However, the next part is what is the maximum volume of the box? So what we're going to do is we're going to take V of 3.6812. So I'm going to take that number and I'm going to back substitute it in there. And so when I do that, I end up getting 820.3453 inches cubed. All right, the next problem, we have a rectangle bounded by the x-axis and the semicircle y equals square root 25 minus x squared. So this has come up before this year. We have to recognize that that is a semicircle. All right, it's in the form of x squared plus y squared equals r squared, but it's solved for y. And so it's not a plus or minus in this case, but it's just a positive square root. So we end up having that semicircle just like that, and that has a radius of 5 because 5 squared gives you 25. And so we should recognize that even without seeing the picture. And it's asking what is the length and width so that my rectangle should have its area be a maximum. Well, we're not just looking at the picture. We need to figure out this area of this rectangle being a maximum. So we need to figure out an equation. So my area of this rectangle, this would end up being x, however far x we go. But if that's x, this would also be like a negative x. So in this case, I'm just going to say it's 2x. And then, how far does it go up? Well, it goes up y. So my area equation is 2x times y. But right now I have two variables, so I don't want to take a derivative like that. But what is y? Y is this square root function. So my area equation is a equals 2x times the square root of 25 minus x squared. I can't really simplify it any more than that, so now we're just going to take a derivative. So dA dx, so the derivative of my first, so the derivative of 2x is 2, and then times the second, I'm going to call it 25 minus x squared to the 1/2. I think will help us out seeing it later. And then plus, because this is a product rule, so I bring down the 1/2, and then I have 25 minus x squared to the negative 1/2. However, what pops out by the chain rule? A negative 2x. And then times the first of 2x. So now we need to simplify this up a little bit. So this plays really nice because this 1/2 and the 2, they kind of cancel to go to 1. So that's pretty nice. And then we have a 2 and we have a negative 2. So I'm going to factor out a 2. And then we're going to factor out the least power. So I have a 25 minus x squared to the negative 1/2. And I also have a 25x minus x squared to the 1/2. So I'm going to factor out to the negative 1/2. And so now what we're left with is I already factored out a 2, and I factor out a negative 1/2 power from 1/2 power. So we're just left with 25 minus x squared to the power of 1. And that's the whole reason behind why we do it. And then I now have a negative 2x times x. Oh, actually, I already factored out the negative 2. So I just have x times x, so we end up having a minus x squared. So now let's simplify that up a little bit. So up top in my numerator, I still have this 2, and then I have 25 minus x squared, and x squared become 2x squared. And then it's over, this goes to the basement, so that's over 25 minus x squared underneath the square root. So that is my derivative. So I'm going to take that derivative and I'm going to set it equal to 0. Now, when I set something equal to 0, I'm going to multiply by that denominator, so that kind of goes away. I could divide by 2, so that kind of goes away. So truly what I'm doing is I'm setting 25 minus 2x squared equal to 0. So when I set that equal to 0, I really get 25 equals 2x squared. So then I divide by 2, so now I have 25 over 2 equals x squared. Then we need to solve, so we're going to square root it now. Truly, we have a plus and minus going on. So I end up getting x is equal to plus or minus the square root 25 over 2. Now, it doesn't really make sense to have a plus or minus because my x is going in that positive direction. So what's the square root of 25? We get 5 over square root 2. Or I could even say 5 square root 2 over 2. However, that is not any of my answers to my question. That's what x equals. So if x is equal to, right here, that's not even a length or a width of this rectangle. So now what I really need is I really need 2 of them, right? And so I end up having 5 square root 2 as one of my lengths. Well, I need to solve for y. So remember, y is this 25 minus x squared part. So let's go ahead and substitute that in. So I personally think of it that right here. So then we end up getting y is equal to square root of 25 minus, and then we end up having the square root of 25 over 2 squared. So we end up having 25 minus 25 over 2, which is, again, the square root of 25 over 2, which is the same thing as saying 5 over square root 2, or 5 square root 2 over 2. So my height is 5 square root 2 over 2. And just like the one where we did on the river problem of Gandy's Ranch, it ends up being 2 squares. All right, so that is how we find the maximum area. All right. So you have a few problems to work on optimization. So spend a little bit of time on optimization and then go ahead and start your Chapter 3 review. The solutions to the Chapter 3 review are already posted. Have a wonderful day, and I hope to see you soon.